At exactly 5 a.m. on a commercial fishing dock in northern Wisconsin, the surface of Lake Michigan remains steel-colored under a lifting pre-dawn sky. A third-generation commercial fisherman named Charlie has spent 40 consecutive years pulling gillnets from these exact coordinate blocks. This morning, the mechanical winch hoists a net that comes up unexpectedly heavy, spilling a 200-pound haul of lake whitefish across the aluminum deck. The fish exhibit the precise phenotypic markers of the region's native stock, deep silver flanks and black-tipped caudal fins, identical to the specimens harvested from these waters when Harry Truman occupied the White House. Yet, according to every predictive population model published by federal ecological boards between 1888 and a decade ago, these fish should not exist inside that net. The data models had finalized a definitive timeline for total systemic collapse. The third-generation fisherman is looking at a biological anomaly that state-funded management frameworks explicitly declared an impossibility within living memory. The predictive models were not undermined by the whitefish themselves, but by a microscopic organism that entered the Great Lakes Basin in the summer of 1988 inside the ballast tank of an unregulated transatlantic freighter. The subsequent expansion of this invasive filter feeder triggered the most expensive aquatic crisis in modern American history, draining over $12 billion in government and industrial mitigation funds. Federal engineering programs, chemical treatments, and mechanical control structures completely failed to stop the replication cycle. However, where a $12 billion state infrastructure cratered, an uncoordinated, autonomous natural counter-defense network silently activated. This investigation deconstructs how 3 heavily disparaged or entirely ignored native species altered their life histories, modified their internal anatomy, and bypassed human management protocols to execute a massive, multi-column purification miracle for free. Calibrating a structural infiltration of this magnitude requires pinning down our exact geographic baseline. Log your specific state, province, or drainage basin in the comments section below, noting whether your regional land corridors are currently tracking under heavy industrial stagnation or active biological recovery. If you believe this hidden data map needs to reach more analytical minds, authorize a share of this post right now to push this independent investigation straight through the algorithmic noise. Let's return directly to the dock lines, because this prehistoric ecosystem was about to launch a silent, uncoordinated counter-offensive. But to make any sense of how the lake survived, you first have to understand what arrived in 1988. The organism is called Dracaena polymorpha, the zebra mussel. It entered Lake St. Clair inside the ballast tank of a transatlantic freighter, and within 18 months, biologists monitoring the lake bottom were reporting something they initially dismissed as a data error. The replication numbers were not plausible. A single female zebra mussel lays up to 1 million eggs per spawning season, 1 million per female per year. Within 2 decades of that single ballast discharge, the species had colonized waterways across 38 states, carpeting intake pipes, clogging filtration screens, and sealing off municipal water infrastructure with calcified biological armor up to 8 inches thick. The first time most Americans paid for this invasion, they didn't know it. In the summer of 1989, the Monroe, Michigan Municipal Water Treatment Plant shut down for 3 consecutive days after zebra mussels choked its intake systems completely. Residents opened utility statements they couldn't explain. The $12 billion in federal remediation funding that followed did not arrive as a single visible line item. It arrived quietly, embedded inside water rates, infrastructure repair contracts, and power generation surcharges paid by people who had never heard the words Dracaena polymorpha. The invasion was everywhere. The bill was invisible, and every mechanical solution deployed against it, scraping, chlorination, filtration upgrades, bought months, not decades. Deconstructing a generational wildlife crisis requires an audience of analytical minds who value cold, diagnostic telemetry over superficial, emotional conservation stories. If you align with this level of independent investigation, formalize your entry into our research network, by hitting that subscribe button right now. If the unvarnished facts we uncover matter to your perspective, drop a quick like on this post to tell the algorithm this raw data sequence deserves priority engagement. Now, follow the timeline straight into the waterfall monitoring blind, because the moment the migrating flocks arrived, the behavioral data shattered the public despair. But while America has been paying and paying, 3 native species have quietly been doing what the tax dollars never could. The first wave came from the air. USGS waterfowl specialists Christine and Thomas Custer began tracking something anomalous in the foraging behavior of migrating diving ducks moving through the Great Lakes corridor in the years following the invasion. The birds were changing, not gradually, decisively. Common goldeneye, historically opportunistic feeders, had restructured their aggregate diets until zebra mussels comprised 80% of every caloric intake recorded. Lesser scaup had gone further. Nearly 100%. These birds had effectively abandoned their ancestral feeding patterns and repurposed themselves as biological extraction units targeting the exact organism the federal remediation program couldn't contain. The Custers needed hard proof. They got it at Point Pelly, Ontario. Inside wire exclusion cages that physically blocked duck access to mussel beds, biomass accumulated unchecked. Outside those cages, in open water where the birds dove freely, invasive mussel biomass dropped by more than half. No chemical treatment, no infrastructure contract, no federal invoice. Ducks for free. 3 data points, 1 replication curve, 1 municipal shutdown, 1 50% biomass collapse, all pointing at the same shape. The biological counteroffensive was already running. But the data Custer's team hadn't yet fully processed was about to reframe every number in this chapter as something far darker than a victory. But here is where this story darkens, and it darkens early. The containment of the crisis wasn't a clean victory. Zebra and quagga mussels are hyper-efficient filter feeders. That is the precise mechanism that makes them so ecologically destructive. They pump lake water through their tissue at extraordinary rates, stripping out particulate matter and clarifying the water column with industrial thoroughness. What the federal remediation reports did not prominently feature is what those mussels retain inside their flesh while doing it. Cadmium, selenium, PCBs, and mercury, accumulated from decades of Great Lakes industrial discharge, concentrated and locked inside soft tissue at levels that exceed safe thresholds by measurable orders of magnitude. The mussels were not just an invasive species. They were a biological storage system for every toxic legacy the basin had ever absorbed. The lesser scaup were eating nearly nothing else. Ecotoxicologists tracking the continental breeding population documented the collapse across 2 decades of survey data, 7.5 million birds down to under 4 million. The birds didn't fail to adapt. They adapted perfectly, and the adaptation was killing them. The animal that saved the lake was being destroyed by the act of saving it. This profound divergence between a species' historical native range and its true evolutionary ecosystem limit is actively throwing global restoration plans into chaos. If you believe real-world engineering data like this needs to be shared, take a second to hit that share button to broadcast this file directly to your own network. Look closely at the biological hardware required to crack the deepwater reefs, because the next native species in this counteroffensive was one that management agencies had spent a century actively trying to erase. Now, here's what you need to understand about the deepest part of this problem. The diving ducks could reach the shallow reefs. They could not reach the lake trenches, where adult zebra mussels carpeted the benthic substrate in calcified armor several shells deep, entirely beyond the bird's physiological dive ceiling. To clear those zones, the ecosystem required an animal with fundamentally different hardware, a predator capable of taking a fully calcified adult mussel into its mouth and crushing the shell outright. That is not a behavioral adaptation. That is a question of anatomy. Either the bone structure exists in the jaw or throat, or it does not. In North America, that hardware existed in exactly 1 freshwater fish, and we had spent a century throwing it on the bank. The freshwater drum, a species so aggressively maligned by state management agencies that fishing guides across the Midwest distributed literature actively instructing anglers to kill them on sight and leave the carcasses on the shoreline. In 1997, USGS biologists John French and Michael Burr published the anatomical study that reframed that century of institutional contempt as one of the costliest biological errors in American conservation history. Their finding was precise. Once a freshwater drum crosses exactly 26.5 centimeters in body length, the pharyngeal mill in its throat remodels into flat, molariform grinding plates capable of pulverizing adult mussel armor completely. The trash fish was the only fish built for the job, which meant the third wave of this counter-offensive belonged to the species the invasion was supposed to kill outright, and what that fish did next, no recovery plan had ever asked it to do. Which left one question, the deepest one, about the fish that the zebra mussel was supposed to kill outright. What they did next, no recovery plan had ever asked them to do. The lake whitefish had built its entire metabolic existence around a tiny native crustacean called Diporrhea, a benthic shrimp that once comprised 70% of the whitefish's annual caloric intake across the Great Lakes basin. When the zebra and quagga mussel colonies expanded across the lake floor, they consumed the particulate organic matter the Diporrhea depended on and collapsed the shrimp populations systemically. Within a decade of the invasion, NOAA researcher Steve Pothoven's tracking telemetry documented the dietary shift in precise terms. Diporrhea had dropped from 70% of the whitefish diet to 25%. The whitefish were starving in open water. Body condition indices recorded by federal monitoring stations showed mass fat reserve collapse across the commercial stock. These were the fish Charlie's grandfather had pulled from these same coordinate blocks without incident for 40 years. They were running out of food on a lake covered in mussels. And then the whitefish did something no anatomical study predicted and no recovery framework had modeled. Without grinding throat hardware, they couldn't crack adult shells, so they stopped targeting adults entirely. Pothoven's telemetry revealed a wholesale behavioral pivot. The whitefish had learned to intercept free-drifting mussel larvae and soft-shelled juveniles in the water column, hunting the invasion at its most vulnerable developmental window before the armor could calcify. Not grinding the mussel, not avoiding it, eating it before it could become the thing that was killing everything else. 3 native species, no coordination, no management directive, all converging on the same biological problem from 3 completely different evolutionary angles, and the bill for all of it was 0. Which makes what Charlie finds inside that whitefish stomach at 5 in the evening the most important data point in this entire file. So back to Charlie at the dock. It's 5 o'clock in the evening now, but, and this is the honest second half of the story, the cost is still moving. He pulls a 5-pound whitefish from the deck and runs a fillet knife along the lateral line. When he opens the stomach cavity, 8 mussel shells tumble out, half digested, still bearing the characteristic striped pattern of Dracena polymorpha. This is not a conservation success story. This is what a food web looks like when it stabilizes around a toxic nucleus. The 2024 Ecotoxicology Review that synthesized 3 decades of Great Lakes contaminant data reached a conclusion that no remediation press release has prominently featured. Nature absorbed the invasion, but it did so by routing mercury, cadmium, and PCBs upward through every trophic level the mussels now anchor. The whitefish in Charlie's net are eating contaminated larvae. The walleye eating the whitefish are accumulating the load. The people eating the walleye are the end of the chain. $12 billion failed to stop the invasion. 3 animals no one was watching largely contained it, and the equilibrium they built is quietly poisoning the food web from the bottom up. The question is no longer whether native species can outperform industrial remediation. The question is whether we are capable of recognizing the value of an ecosystem component before the crisis that reveals it, or whether we will spend the next century identifying the next trash fish only after we have spent a generation throwing it on the bank. If our existing conservation frameworks are trapping dying lineages inside static historical borders, that actively clash with their evolutionary needs. The entire global rulebook is obsolete. Drop your definitive analysis on assisted migration below alongside your home coordinate. And if this investigation fundamentally exposed a flaw in how you calculate ecological value, leave a like on this post and secure your subscription to Earth Discovery Series. Because in our next case file, we open a file where the establishment had already written the obituary, and the subject hadn't finished reading it yet. Charlie seals the cooler. The lake is the same color it was at dawn. The fish that shouldn't exist are on their way to market. And somewhere in the deep water below, the counter-offensive that no one authorized is still running.